All right, guys. This is the chapter 14 notes, and so what I'm going to do here, just for the next couple days while I'm going to be gone, I'm going to give it a shot. What I'm going to do is I'm going to go through the written out notes. I'll go through all these first, and that'll be the first video. And then the second video that I have is the video of examples to go through, kind of explaining and showing you how to do examples so that you can be better prepared on how to complete your practice problems. Okay, so this first video we're going to talk about. It's going to go through the notes, and again, I have these notes on Schoology, so you can load these, and if you want to take snapshots of these, it doesn't really matter on how you do this. If you want to write these down, whatever's more comfortable for you, okay, but I will have these posted on Schoology as well. Chapter 14, we are talking about, we're going to start talking about probabilities, and all the different ways to find all the different kinds of probabilities that we can use. And I think you'll like this chapter, this unit. I skipped to unit 4 so we could get to this because some of this stuff's kind of fun and it's kind of you can do some interesting things with it. So I'll start with this random phenomenon. Random phenomenon. Okay, so first of all, let's talk about the word random. Something that is random is something that you cannot predict. Okay, there is no pattern to it. There's nothing like that. So when we talk about random phenomenon, we know what outcomes could happen. For example, I can give you the list of things that could happen, but I don't know what's exactly going to happen at this one time. So random phenomenon is we know what outcomes could happen, but not which particular values will happen. For example, I can flip a coin, and I know I'm either going to get heads or tails, but I don't know which one I'm going to get. And I can try to predict it, but that doesn't mean I'm going to get it right. Okay. A lot of this stuff, guys, by the way, is vocabulary. Tons of this stuff is in chapter 14. So a trial is a single attempt or realization from observing a phenomenon. Okay, a trial. An outcome is the value measured, observed, or reported for an individual instance of a trial. So a trial is essentially a bunch of outcomes put together. An outcome is a single item. Okay, so I might do a trial of 5 flippings of the coin. Okay, but one outcome of those 5 flippings might be a heads. Another outcome might be a tails, so forth and so on. Okay, an event is a collection of trial outcomes. Okay, an event is a collection of trial outcomes. All right, sample space. Okay, this is a sample space. It's very important. This is the part you're going to have to be able to look at and do. A sample space is a collection of all possible outcome values. It's written as a set in set notation. So there's braces here like this, and then you write down the possible outcomes that could happen. That's the sample space. For example, if I wanted to write the possible outcomes for flipping a coin, my possible outcomes would be a heads and a tails. Those are the possible outcomes around the braces. Okay, so those are that would be my sample space for flipping a coin. Okay, a couple things with probability. An independent event, obviously independent means it's something that can stand on its own. It's learning that one event occurs does not change the probability that a second event will occur. Okay, so an independent event is something where if I do something the first time, it has nothing to do with the second time. It's not going to affect it whatsoever at all. The law of large numbers. Again, if you read chapter 14, you would have come up with this, you would have seen this. The law of large numbers is in the long run, okay, the long run relative frequency of repeated independent events gets closer and closer to the true relative frequency as the number of trials increases. Okay, in other words, the more you conduct the experiment, the closer you get to theoretical probability. Okay, so here's the best way I can kind of think of this and describe this. Okay, law of large numbers. I'll use Frankie Fiddler as an example, okay, in basketball. Let's say Frankie Fiddler's average three-point percentage is 33%, okay? And he comes out in this game, in one game and he shoots 85% from three-point land. Does that mean that he's an 85% three-point shooter? No. That was just one game. Okay? The law of large numbers says the more games you put together for Frankie, the closer he's going to get to his 33% that he averages. Okay? So, for example, one game he might shoot 85%, but then the next game he might shoot 15. Well, then the next game he might shoot 35. Eventually, the more games you can put together, the more accurate may not be the best word, but the more the better prediction you would have, I guess is the best way to put that. Okay, so the law of large numbers, the more numbers you can put together, the more trials you can put together, the more accurate you are going to be to the average. Now, the law of averages. Okay, the law of averages is very important. This does not exist. An event is never due to happen. Okay, for example, let's say, again, you go back to using Frankie for an example. Frankie's hit 5 threes in a row. Well, law of averages says, oh, he's going to miss the next one. Well, that doesn't mean that that's going to happen. Okay, nothing is ever due to happen. Or if you use, for example, casino game, you use roulette, and they spin the wheel and it comes up on black, and it comes up on black like 10 times in a row. Well, you can't say, well, because of the law of averages, it's got to be red. Well, that's not the way it works. Okay, an event is never due to happen. So law of averages, it does not exist. All right, probability. Probability, this is an important part here. Okay, as we talk about probability, probability is a number between 0 and 1. That's a very important part. And it reports the likelihood of an event occurring. It's always between 0 and 1. Probability will never be outside of those two numbers. Okay? So, empirical probability. The experimental or empirical probability is the probability that comes from the long-run relative frequency of the event's occurrence. Okay, so how do I find the probability using experimental probability? Well, I take the number of times an event occurs, or a number of times A occurs, over the total number of trials. Okay, so for example, it says here you toss a coin 10 times and heads shows up 7 of those 10 times. What's the empirical probability of getting a tails on the 11th toss? Okay, well, you toss the coin 10 times and the heads shows up 7 of those times. What was the empirical probability that you would get a heads? Well, that would have been 7. You got 7 times you got heads out of 10 total tosses. Okay, now, what is the empirical probability of getting a tails on the 11th toss? Well, if I tossed it 10 times and I got 7 heads, that means I got 3 tails. So my empirical probability is 3 out of 10 total. Okay, 3 out of 10. There were 3 that ended up being tails. There were 10 total times. Now, theoretical probability is much more of what we look at in terms of most of the probabilities we're going to do. Okay, theoretical probability is the probability that comes from a model. It's usually dealing with equally likely outcomes. Okay, this does not mean that these are equally likely all the time. Okay, so how do we find theoretical probability? Well, the probability of an event A is the number of outcomes in A over the total possible number of outcomes. Okay, so it says here, example, you toss a coin 10 times, and a head shows up 7 of those times. What's the theoretical probability of getting a tails on the 11th toss? Well, as you look at this example, okay, theoretical probability wants to know, okay, how many heads are there, and how many possibilities are there? Okay, well, how many number of outcomes are there for tossing a coin, for getting a heads? There's only one. Okay, there's one way to get a heads. There's one out of, in this case, how many total possible outcomes? Well, when you flip a coin, you either are going to get heads or you're going to get tails. So it's 1 out of 2. Okay, there's only one heads and there's 2 options. It's either going to be heads or tails. 1 out of 2. Okay, so now as we look at the rest here, and don't worry, I'll go through some more examples on the examples portion of the video, okay? But let's go finish this note stuff up here. All right, personal or subjective probability. It's when probability is subjective and represents your personal degree of belief. It's often used by doctors, market analysts, and meteorologists. Okay, the personal or subjective probability is much different. Okay, now this next part is another part that's going to be important, and that is disjoint events. What does it mean to be disjoint? Well, it means to be separated. Okay, so as we look at disjoint events, if I were to draw like a Venn diagram, these events are disjoint. Okay, they're totally separate. One has no effect on the other. Okay, these events are not disjoint. Like so. Okay, you'll notice those two circles overlap to each other, so they have something in common. Okay, mutually exclusive events are two events that have no outcome in common. Okay, so mutually exclusive. These guys up here are mutually exclusive, right here. Okay, not mutually exclusive means they're not disjoint. That means that they have possibilities of, in other words, they have outcomes in common. Okay, for example, when you flip a coin, what are your possibilities? Well, your possibilities are heads or tails, right? Now, can you flip a coin and be a heads and a tails at the same time? Well, obviously no, you can't. That's not possible, right? Okay, but if I roll a dice, okay, I take a die and I roll a die. You have 6 possibilities on the die. 1, 2, 3, 4, 5, or 6. Okay? You can get any one of those 6 things. 1, 2, 3, 4, 5, or 6. I want to know what the probability is of you getting a 1. Well, can you be a 1 and be anything else at the same time? Can you be a 2 and a 1 at the same time? No. Those are disjoint. Okay? Those are mutually exclusive things. Now, what happens if I ask you what's the probability of an even number? Okay, probability of an even number. Now we start diving into things, for example, a probability of an even or a 4. Well, can you be even and a 4 at the same time? Yes. Those two things are not mutually exclusive. They're not disjoint. Because if I have evens, okay, if I have evens, for example, the odds would be 1, 3, and 5, and then I want 4s, and then 2 and 6. Okay, so they would share the 4. So they're not disjoint, if that makes sense. And like I said, you'll see more examples of when we're going through here on the examples portion. It'll probably be a better understanding of it then. All right, formal reporting. You use decimals or fractions rather than percents. So everything that we're going to use is going to be either fractions or decimals. Formal probability rules. And this is important stuff, and we've talked about this before. Probability must always be between 0 and 1 for any event. So you'll see it written like this in this notation right here. For any event A, the probability that something occurs has to be between 0 and 1. If it's not between 0 and 1, it's not true probability. Okay, the probability assignment rule. Probability assignment rule says the probability of the entire sample space must be 1. Thus, the sum of all possible outcome probabilities must be 1. If you add up all the probabilities and it's more than 1 or less than 1, then it's not true probability. Okay, the complement rule. Again, I'm going through all these rules, but you'll see me go through examples of these here eventually. Okay, the complement rule, and it's really pretty easy. The complement rule says the probability of an event occurring is 1 minus the probability that it does not occur, and vice versa. Okay, for example, if I want the probability of not getting a 3, if I roll a die, and the probability of not getting a 3. Well, as I look at this example, okay, the probability of me getting a 3 is 1 out of 6. So what's the probability of me not getting a 3? Well, if there's probability of me getting a 3 is 1, that means there's 5 other options left over because I took 6 minus 1. Okay, so in other words, if I ask for the probability of you getting a 3, that's 1 out of 6. The probability of you not getting a 3 is 5 out of 6. And you'll notice that those two, 1 out of 6 and 5 out of 6, both add up to 6 out of 6. They'll always add up together. Okay, so the complement rule. The addition rule. It's for two disjoint events, A and B. Disjoint means they're not mutually exclusive. The probability that one or the other occurs is the sum of the probabilities of the two events. Okay, we use the term or. Now, this is what it's going to look like, and I explained this here in just a little bit on the bottom of this here, a little bit what this looks like. It says the probability of A in union with B. Okay, probability of A in union with B. That essentially means we're going to take the probability of A and we're going to add that to the probability of B. For the multiplication rule. Multiplication rule is for two independent events, two events that stand alone. Okay, one doesn't affect the other, A and B. The probability that both A and B occur is the product of both probabilities. It uses the term and. Okay, so I want to know what's the probability of you getting a 3 and a 4. There's a key word there. Or I want to know what you're going to the probability of you getting a 3 or a 4. They're totally different problems. So the key words here that you're looking for in these examples are or and and. And means you multiply, or means you add. Okay, and again, the probability of A intersecting B, and I explain what intersecting and all that is here down here on the bottom. As a matter of fact, I'll just go ahead and we'll move that up right here. You can see what union and intersection are. A union signifies the joining of one outcome with another, and the intersection signifies the overlap of one event with the other. Okay? So we're going to be working some multiplication, some addition rule examples together in our examples. And then the last part, how do you know it's legitimate probability? Okay? Legitimate probability, it's only a legitimate probability if two things happen. One, each probability is between 0 and 1. So if it's lower than 0 or it's higher than 1, it's not legitimate. And the sum of the probabilities has to be 1 total. Okay, so for it to be legitimate probability, all your probabilities have to be between 0 and 1, and the sum of your probabilities is 1 total. Okay, so this completes the notes section for chapter 14, all right? And like I said, in video 2, I'll be going through examples so you can kind of get an idea and see on how probability works.